Okay, so in previous class we are discussing about the carbon arc welding. Okay, so in electric arc welding, so the electric arc welding is mainly classified into how many types? 5 types. What are those? Carbon arc welding, metal arc welding, atomic hydrogen arc welding, inert gas metal arc welding, submerged arc welding. Okay, in previous class we are discussing about the carbon arc welding. Okay, so now in this class we can discussing the remaining these are arc weldings. Okay, so coming to the metal arc welding, in metal arc welding the electrodes used must be of the same metal. Okay, so as that of the metal piece to be welded. Okay, here the electrodes, okay, here the electrodes are the made of same material. Okay, and the metal which is to be welded. Okay, so if suppose that is you want welding the which metal, but and here you can use the electrodes also same that of same metal. Okay, so the electrode itself forms the filler metal. Okay, so at that time the electrode itself forms the filler metal to done the welding. Okay, an electric arc struck by bringing the electrode connected to a suitable source of electric current. See here. So you can see the diagram, you can understood. Okay, so this is the electrode. Okay, this is the electrode holder. Why? Because here to put to hold this electrode, here you are using the electrode. Okay, so and this is a base metal. Okay, so for this base metal and this electrode, here you have to giving the single phase AC supply or DC supply. So for arc welding you can use any supply. Okay, so either AC or DC. Okay, whenever you can give any supply, so at that time the current will passes through the electrode and the current passes through the base metal or workpiece. Okay, on this. Okay, so on this you have to be here you have to welding this part. Okay, so at that time you have so the itself here in the air gap the arc will be exist. Okay, so and this arc will melt this electrode. At that time it will forms the filler material. Filler material by filling. That means that electrode will be melted. Why? Because so that electrode will be melted. Okay, so that metal total will be welded on this base metal. So here there is no problem. You are filling this metal. Why? Because here you have to use the same metals. That means base metal will be same, and here the electrode which is to be and here the electrode is also same metal of the base metal which is to be welded. Okay, so that's why this is called metal arc welding. Okay, so and here see. The arc produced between the workpiece and the electrode results high temperatures of the order of 2400 degrees centigrade at negative metal electrode. Okay, and electrode at positive base metal workpiece. So, and it see here it can produce as the 2400 degrees centigrade. If suppose you are using the positive electrode, so at that time it produces 2600 degrees temperature. If suppose we are using the negative electrode, so at that time it produces the 2400 degree centigrade. Okay, so this is the metal arc welding. Okay, see here these high temperatures of the arc melts the metal as well as the tip of the electrode. Then the electrode melts and deposited over the surface of the workpiece and forms the complete weld. So previously I will say that. Okay, the tip of the electrode. Here the electrode tip will be melted. Okay, and this total filler material will be deposited on the metal. Okay, so both AC and DC can be used for the metal arc welding. So previously I am said that so either AC current or DC current. Okay, both currents will be used for the welding. The voltage required for the DC metal arc welding is about 50 to 60 volts. If suppose if we have to given the DC supply, so at that time it requires the voltage of 50 to 60 volts. So and for the AC metal arc welding, if suppose we are using the AC metal arc welding, so at that time it uses the 80 to 90 volts. Okay, so in order to maintain the voltage drop across the arc less than 30 volts, the arc length should be kept as small as possible. Okay, so see to maintain the arc between the electrode and the metal which is to be welded, so at that time it requires, okay, to maintain the arc it requires the voltage of 13 volts. Okay, so the current required for the welding, okay, to do the welding process, the current will be required will be varies from 10 to 500 amperes. Okay, so but this having one main disadvantage. Okay, so the metal arc welding having one main disadvantage. Now you can see that what is that main disadvantage means. The main disadvantage in the DC metal arc welding is the presence of arc blow. Okay, here what is the arc existing between the electrode and the metal, so that will be always blow. Okay, that is the distortion of arc stream from the independent path due to magnetic forces of the non-uniform magnetic field. AC arc blow is considerably reduced. Okay, so the main disadvantage in DC metal arc welding is presence of arc flow. Okay, so at that time it will be distorting the arc path. Okay, so that's why you are mainly using the AC metal arc welding. For obtaining the good weld, the flex coated electrodes must be used. Okay, for obtaining the, so to do the good welding, here we are using the flex coating electrodes. Okay, so the metal which is melted covered with the slag produces a, so and the metal have covered with the slag. Why? Because produces a non-oxidizing gas or molten slag to cover the weld. Okay, so that means to stabilize the arc, you have to must use the flex coated electrodes. Okay, so what is the third welding? Third electric arc welding, atomic hydrogen arc welding. Okay, see, in atomic hydrogen arc welding, the heat for the welding process is produced from an arc struck between two tungsten electrodes in an atmosphere of hydrogen. Okay, here that means generally here the arc, so in previous cases the arc will be struck in the air gap. That means between electrode and metal plate you have to air. Okay, so and that one the arc, but here the arc will be struck between two tungsten electrodes in the presence of hydrogen. Okay, that means in surrounding places, that is total electrodes are placed in hydrogen. Okay, so that's why this is called as atomic hydrogen arc welding. Okay, here hydrogen serves mainly two functions. Why you are using the hydrogen means it having two functions. One act as a protective screen for the arc and other act as a cooling agent for the glowing tungsten electrode tips. Okay, so that means here the hydrogen is mainly serves two functions. What are those means? One act as a protective screen. Okay, so for the arc, okay, for the arc it is act as a protective screen, and another one is it act as a cooling agent for the glowing tungsten electrode tips. Okay, so whenever the arc will be struck between the electrodes, at that time the tungsten tips will be melted. Okay, to cool that tungsten tips, here you have to use the hydrogen. As the hydrogen gases pass through the arc, the hydrogen molecules are broken up into atoms and absorbs the heat from the glowing tungsten electrodes, so that these are cooled. So in which way this hydrogen will be cools the electrode means, so whenever the arc will be struck between the electrodes, so at that time this hydrogen gases will pass through the arc, so at that time the hydrogen molecules are split into the atoms. Okay, at that time that atoms will absorb the heat from the glowing tungsten electrodes, so that these are cooled. Okay, so in this way the tungsten electrodes will be cooled. See here, this is the process. Okay, so here this is the filler rod. Okay, this is the hydrogen gas. See, these two are this is one electrode, this is another electrode. Two tungsten electrodes. Two tungsten electrodes are placed in hydrogen gas. Okay, so here you have to welding this portion. Here you have to place the filler rod. Filler rod means so whenever this will be melted by using this filler rod, you can fill this total the base metal which is to be welded. Okay, whenever you have to giving the AC supply to these electrodes, so at that time the arc will be struck between these two electrodes. Okay, so that by using that arc, here the filler rod will be melted. Okay, so that filler rod and this tungsten will be filled in this base metal. Okay, that is the metal which is to be welded. Okay, this is the process of atomic hydrogen arc welding. Okay, so see, but when the atoms of hydrogen recombine into the molecules outside the arc, a large amount of heat is repleted. So here, so I am says that whenever heat will be produced, there is the tungsten tips. At that time, so these hydrogen molecules will be split into the atoms. Okay, so whenever again these atoms of hydrogen will be recombined into molecules outside the arc. Okay, so at that time they can produce a large amount of heat. Okay, the extra heat is added to the instance heat of arc, which produces a temperature about 4000 degrees centigrade is sufficient to melt the surfaces to be welded. Okay, so at that time, so extra heat will be produced. So that is around 4000 degrees centigrade temperature will be produced. Okay, so the temperature will directly welded the surface. Okay, so together with the filler rod if used. Okay, so by so that means by using this 4000 degrees centigrade heat, the filler rod will be melted. Okay, so and the surfaces to be welded. Okay, moreover hydrogen includes oxygen and some other gases that might combine with the molten metal and forms oxides and other impurities. Okay, so hydrogen includes some amount of oxygen and some other gases. Okay, those are combined with molten metal. Okay, that means the metal which is to be welded, so and forms the oxide and other impurities. Okay, hydrogen also removes oxides from the surface of the workpiece. Okay, so what are the oxides produced on the workpiece? That means the surface which is to be welded. Okay, that will be removed by using the oxygen. Thus, this process of capable of producing strong, uniform, smooth and ductile welds. Okay, by using this atomic hydrogen welding, okay, you can producing the weld is very strong, okay, uniform, smooth and ductile welds. Okay, so in atomic hydrogen arc welding, the arc is maintained between the two non-consumable tungsten electrodes under a pressure of about 0.5 kg per centimeter square. Here the arc will be produced between the two tungsten electrodes, and the two tungsten electrodes are placed at a pressure of 0.5 kg per centimeter square. Okay, so in order to obtain equal consumption of electrodes, AC supply is used. Okay, here more cases you have to use the AC supply for this atomic hydrogen arc welding. Arc currents up to 150 amperes will be used. Okay, for this process the arc current will be used up to 150 amperes. High voltage about 300 volts is applied for this welding through a transformer. Okay, so for this welding process it requires the 300 volts voltage. For striking the arcs between the electrodes, an open circuit voltage varies from 80 to 100 volts. That means to maintain the arc between the two tungsten electrodes, okay, so here you have to use the voltage 80 to 100 volts. Okay, as the atomic hydrogen welding is too expensive, it is usually employed for welding alloy steel, carbon steel, stainless steel, aluminium, etc. Okay, see this atomic hydrogen welding is very expensive, so that's why it is usually employed for the welding of alloy steel, carbon steel, stainless steel and aluminium, etc. Okay, so this is about the atomic hydrogen arc welding. So next one is what? Inert gas metal arc welding. Okay, coming to the inert gas metal arc welding, it is a gas shielded metal arc welding in which an electric arc is struck between tungsten electrode and workpiece to be welded. Okay, here you have to use the electrode will be tungsten electrode, and so here the arc will be struck between the tungsten electrode and the workpiece which is to be welded. Okay, filler metal may be introduced separately into the arc if required. Okay, so filler metal. Okay, so if suppose you can require extra arc, so at that time maybe you can introduce the filler material. A welding gun which carries a nozzle, through this nozzle inert gas such as beryllium or argon is blown around the arc onto the weld. Okay, so why this is called inert gas metal arc welding means whenever the arc will be striking by using the one electric gun, through that electric gun you have to pass around that arc, you have to place the either inert gas, that is either beryllium or argon. As both beryllium and argon chemically inert, so the molten metal is protected from the action of the atmosphere by the envelope of chemical reducing or inert gas. Okay, so at that time the molten metal is reduced from the action of atmosphere. Okay, so why? Because these are protecting these beryllium or argon are act as the protecting layers for the arc, as the molten metal has affinity for oxygen and nitrogen if exposed to the temperature, thereby forming their oxides which makes weld leaky and brittle. So generally, so whenever you have to not place this beryllium or argon, so at that time the molten metal if it is able to form the nitrates and oxides with the reaction with the presence of oxygen and nitrogen present in the atmosphere. So at that time it makes the weld visible leaky. Okay, that means the weld either may be leaky and brittle. Okay, so this is the inert gas metal arc welding. So here this is the nozzle, this is tungsten electrode. Through this nozzle you have to place the either either argon or beryllium gas. Okay, this is the molten metal, this is the flame. Okay, this is the base metal. Okay, so by using this molten metal you have the welded. Okay, so this is the DC supply or AC supply you have to given. Okay, this is the inert gas, metal or welding. See, thus several methods of shielding have been employed with the use of flex coating electrodes or by pumping the inert gases around the arc produces a slag that floats on the top of the molder, produces an envelope of inert gas around the arc and weld. Okay, so that means here you have to maybe use the flex coated electrodes or by passing the inert gases. Okay, so why? Because to protect the a metal sheet from the atmospheric oxygen and nitrogen. So coming to the advantages of this inert gas arc welding, flex is not required since inert gas envelope protects the molten metal without forming oxides and nitrogens. So here you have to know use of flex coated electrodes. So in the place of flex coated electrodes, here you have to pass the inert gas. Okay, and it which protects the molten metal forming the oxides and nitrogen. So that's why here the weld is smooth, uniform and ductile. Okay, distortion of the work is minimum because the concentration of heat is possible. So there will be distortions occurs in the process of welding is less. Okay, so coming to the applications, the welding is employed for the light alloys, stainless steel, etc. Okay, so in the welding process of light alloys as well as stainless steel, you have to using this inert gas arc welding. The welding of non-ferrous metal such as copper and aluminum, etc. Okay, to weld the non-ferrous metals, copper, aluminum also you have to use the inert gas metal arc welding. So up to this, these are the 5 types of electric arc welding. So remaining one welding is there, that is nothing but the ultrasonic welding. Okay, so ultrasonic welding. Okay, so ultrasonic welding means first you can see that ultrasonic welding. So the welding equipment for the ultrasonic welding is consisting of 2 units. First one is a power source of frequency converters which converts the 50 cycle line power into high frequency electric power. So that means you have to giving the AC supply. So the supply frequency having 50 cycles. Okay, so that 50 cycles power frequency will be converted into the high frequency by using the frequency converter. So next one is transducer. Transducer which changes the high frequency electric power into vibrated energy. See, this is the arrangement of the ultrasonic welding. Okay, so this is the frequency converter. This frequency converter will convert the 50 cycles frequency into high frequency. So this is given to the transducer. This transducer is converting this high frequency energy into the vibrating energy. So that is given to the coupler. Okay, so see, this is the weldment. So welding, so that means the metal which is to be welded, and this having anvil is nothing but support. Okay, that means here you have to joining these 2 work plates, 2 plates. So and here you have to place you have to fix the one plate and you have to join the other plate. Okay, so here by using the vibration. Okay, by using the vibration, here the metals to be welded. Okay, so that's why this is called ultrasonic welding. Okay, so coming to the operation of this one, so whenever you have to giving energy, so at that time, okay, so there's some vibration. Okay, so the clamping force will be exerted by this metal. So at that time these 2 metal pieces, that means here by using the vibration force. Okay, so that's why this is called ultrasonic welding.